On the last part of the guided notes, and we were trying to rewrite the exponential expressions with rational exponents as a single rational exponent. So they had 5 to the 1/3 times 2 to the 1/2. And if you're going to write that as a single rational exponent, you need a common denominator between the 1/3 and the 1/2 in the exponents. So that would be 6 would be the common denominator. So you would have 5 to the 2/6 times 2 to the 3/6. And then now you would, that's the same thing as saying, okay, 5 to the 2nd power times 2 to the 3rd power, but you're taking the 6th root, or to the 1/6 power of both of those. And that's how you rewrite it as a single rational exponent. And then you had 7 to the 2/5 in number 9 of the guided notes times 4 to the 1/2. This time it would be 10 would be the common denominator. So you would have 7 to the 4/10, and you would have 4 to the 5/10. And that would be 7 to the 4th power times 4 to the 5th power, and then you're taking the 10th root, or to the 1/10 power. And you can simplify those. It only asks you to rewrite it as a single rational exponent, so they could stop there. But I go on to explain, well, what does that actually mean if you did try to simplify it in exact form using radicals. So that's the same thing as saying 25 times 8 on the inside, and you're taking the 6th root in number 8. So you're basically taking the 6th root of 200. And if you break down 200, 20 times 10, 4 times 5, 2 times 5, 2 times 2, you have a pair of 2's. A 2 comes out for that pair because it's basically square root of 4. And then square root of 25, or a pair of 5's, a 5 comes outside the radical for that. And you're left with a 2 underneath, but you're taking the 6th root. Remember that you have to leave it like that. So that's the same thing as 10 and to the 6th root, and the 6th root of 2. Or you can say 10 times, and if you wrote it in parentheses, it's the same thing as 2 to the 1/6. And you can simplify number 9 just like that, but rewrite it as a single exponential expression with a single rational exponent would be this, and this, where you had a common denominator of 10 and you were taking the 10th root of those.